Hi everyone, this is a problem to go over to practice for the assessment tomorrow. You'll have to bear with me, I'm at my son's rehearsal, so there may be noise in the background, so just kind of ignore it. Here's our function, we're going to do all this jazz with it here. But first and always foremost, we're going to factor. So I'm going to factor this here, and let's see, I have a negative 5x and an x, and I'm also going to need a 2. But I see I have an 11, so I might want to multiply that 2 by the 5. And let's see what sign I'm going to need. Let's make this positive and negative. Sorry about that. So I have negative 1 and negative 10 gives me a negative 11, so that works. And the bottom can be factored into x and an x. I have a negative 4 and a positive 2. And there right away I can see that my x plus 2's are going to cancel. And so then I'm left with negative 5x. Oh boy, I've changed sizes of my pen, minus 4. So here's my simplified equation. I'm going to use that one to calculate kind of all my other things here. So let's switch back to a skinnier thickness. There we go. All right, so let's find the domain. So the domain is the set of all real numbers such that x cannot be, well, let's figure out what it can't be. It can't be 4, and it also can't be negative 2. But each of these things, negative 4 or positive 4 and 2, are going to be different pieces of my domain restriction. So my vertical asymptote is whatever factor was not canceled out. So my vertical asymptote is going to be x equals 4. Make sure it's x equals, it's an equation. And my whole is going to be here at negative 2. All right, so I'm going to calculate this whole. So I know the whole is going to be at negative 2, but I need to find what the y value is. And all I'm going to do is just put that back into this problem here, to the simplified problem. So I have negative 5 times negative 2 minus 1 all over negative 2 minus 4. Stop there. So we have 10 minus 9, 10 minus 1 is 9, negative 2 minus 4, negative 6, so negative 3 halves, and we have a negative 3 halves over here. My horizontal asymptote is where I compare the degrees of the polynomials, and I can see they're the same. So when they're the same, it's just going to be y equals the leading coefficients here. And so that's going to be negative 5 over 1, so negative 5. Y equals negative 5 is my horizontal asymptote. The x-intercept is going to come from the numerator here. So I'm going to take negative 5x minus 1 equals 0. We'll solve for x, so negative 5x equals 1. So x is equal to negative 1/5. So I know my x-intercept is negative 1/5, comma 0. My y-intercept is when x is 0. So when x is 0, that cancels, I'm left with that. We can even do it here, this cancels, we're left with 1/4. So my y-intercept is 1/4. Once I have all this information done, I can go ahead and graph. So here's a quick sketch. I'm going to put my asymptotes in first. So 1, 2, 3, 4. So my vertical asymptote is here at x equals 4. And my horizontal asymptote, 1, 2, 3, 4, 5, is going to be at y equals 5. Y equals 5. That's my vertical asymptote. And now we can go ahead and plug in all of these other points. So I have a hole at negative 2, negative 1.5. So negative 2, negative 1.5. Draw a little hole in there. My x-intercept is at negative 1/5, 0. So negative 1/5, 0. Put that there. And my y-intercept is 0 and 1/4, so it's up here. So here I can tell right away that my graph is definitely going to be in this kind of, if you think of dividing this into quadrants, it's going to be here. So I'm going to start down at the asymptote. I'm going to go up to the hole, skip that section, and go up this way. And just because of the nature of rational functions, the other portion of my graph is going to be down here. I'm not looking for super specific points, just looking for you to put it in like the respective like symmetric quadrant over here. Let's fill out the end behavior and asymptotic behavior. So the end behavior is always as x approaches either infinity or negative infinity. So it's what happens at the extremities, and that has to do with this horizontal asymptote. So as x goes to infinity, y is approaching, and I'll write it y this time, y is approaching 5. And as x approaches negative infinity, well, y is also approaching 5. So this end behavior right here is that horizontal asymptote. My asymptotic behavior, so x is always going somewhere in this graph. We always have to incorporate all the 4 spots. So we took care of that direction. We took care of that. Now I need to figure out what happens along this vertical asymptote. So that vertical asymptote is at x equals 4, but it's coming at it from the right and the left. So here I'm going to write f of x. The last one I wrote y. But I want to figure out as x approaches 4 from the right. So as I'm coming along this right side here, even though I'm moving left, I'm still approaching it from the right. The function value goes down to negative infinity. As x approaches 4 from the left, so we're coming in here, we're approaching it from the left, y is going up to infinity.